So we talked about, so we started with the reaction kinetics, and I talked about, anyways, we talked about reactions, the factors that affect the rate of reaction: temperature, pressure, concentration, surface area, catalyst. We did Boltzmann distribution. Up here, we did, I told you that what is rate. When you talk about rate, what do you actually mean? So what you actually mean when rate is mentioned is it's any change with respect to time. The change could be a decreasing change, the change could be increasing, it could be any change, it could be mass change, volume change, color change, any change that could be measured and that could be plotted with respect to time. And the gradient is going to tell you the rate at which the reaction happens. And more importantly, we started talking about orders of a reaction. And now order of reaction was order of reaction was that if A reacts with B, then don't know where A went, just a second. So order of reaction was that if your A reacts with B, particles of A and particles, just 1 second. So particles of A and particles of B will collide. And the rate of the reaction would depend on the concentration of A and the concentration of B. The K is a constant. It's just to get rid of the proportionality sign. So you increase the concentration of A, the rate of the reaction will speed up. You increase the concentration of B, the rate of the reaction might speed up. Okay? There's going to be, if there's more concentrated B, then there's going to be more collisions between A and B. So it depends. And they're going to have a power which is X and Y. These powers or these exponents are known as the order of a reaction or order of reactant. And I told you, so over here, I'm just going to write down the definition of what, because they're going to ask you to explain what is the order of reaction. So the definition of order is, let me write the definition. Now the definition is that it is the exponent. So it is the exponent, or it's a literal definition that it is the exponent of a reactant concentration just hold on, my board is stuck. 1 second. Yeah, I would have to reload this. So anyways, I'll write down the definition later. Okay. But coming back to this, you had powers X and power Y. So every reactant concentration, the rate will depend on that, and it will have a certain power that will be with it. And this power is the order of reaction. So rate would depend on the concentration of A, and the power is going to be the order of reaction. And this order could be 1, and we talked about it. Order 1 means that that rate and the concentration of the reactant are directly proportional. You increase the concentration, the rate will proportionally increase. So that means that it's going to be a linear graph. If you continue to increase concentration of A, the rate will increase. Then you have order 2. Order 2 was that the relationship would be rate would be dependent on the concentration of A. But what will happen is that it's going to have a power of 2. That means that if you double A concentration, the rate quadruples and so on. If you triple A concentration, the rate increases 9 times. So it's a square relationship. It's a quadratic relationship. You continue to increase A's concentration, the rate does not increase proportionally. It actually becomes exponential. It becomes a lot faster. And then the last one was order 0. Order 0 was that it doesn't really matter what the concentration of A is. No matter what you do, rate remains unaffected. Anything to the power 0 is 1. So that means the rate is going to be constant. So it will not change. You continue to increase A's concentration, the rate will remain unaffected and nothing is going to happen. It's going to happen to it. And so we started talking about orders of a reaction, and I talked about that the rate of reaction depends on the reactants. So every equation will have a rate equation. It's going to look like this, and your task is to figure out what the value of x and what the value of y is. So how does rate depend on NaOH and how does rate depend on HCl? What will happen if you double NaOH concentration? Maybe nothing happens. If nothing happens, that means x has a power of 0. If you double NaOH and the rate also doubles, that means x has a power of 1. That means it's directly proportional. And then you'll have a square relationship as well, that if you double NaOH, the rate will increase 4 times, right? So I talked about how do we figure out the order of a reaction. So there were 3 methods to find out the order. The first one depended on the mechanism of the reaction. So ये हमने last time किया था. We're going to start over here. I told you that if you know what the mechanism is. Now this over here is the overall. This over here is the overall reaction. Now the overall reaction does not tell you what the steps are. Okay, there's no. So the overall reaction. So the overall reaction does not tell you what the steps are. This is reactant A, this is reactant B. You have no idea how they're reacting. The mechanism is the one that tells you a detailed path with which the reaction happens. So we wrote down the SN1 mechanism for this. It was a tertiary halogenoalkane. The first thing that happened was that the Cl, it broke off and it formed Cl minus 1 ions. And in the next step, you had the carbocation formed. And then the OH ions came in and they reacted and they formed the alcohol. So it was a 2-step displacement reaction. And I told you that the first step was slow step. The second step was the fast step. Now the reaction does not depend on the fast step. If the first step takes 100 seconds, the second step takes 1 second, then no matter how much you speed up the fast step, the reaction will not speed up. If you continue to increase OH ion concentration, you got 2 reactants, right? So you continue to increase OH ion concentration, the OH ions are involved in the fast step. No matter how much, what you do, if you increase the concentration 1,000,000 times, the fast step becomes from 1 second, it becomes really fast and it goes to 1 microsecond even. The overall speed of the reaction will remain almost unaffected, which means that 100 second plus 1 second, that's 101 seconds. So it will at best go down to 100 seconds. That's a negligible decrease. So that means no matter how much you increase OH ions, speeding up the fast step has literally no effect or almost no effect on the rate of the reaction. What will affect the rate of the reaction is the slow step. You increase the slow step speed, the rate will increase. From 100 seconds, if it goes down to 50 seconds, the reaction is going to be considerably faster. So it will depend on the concentration of this particular reactant, not the other one. ये सारा clear था, Alicia? Abhi, is this clear? Umar, Jana, is this clear? So, and we will do more. We'll practice more examples like this. So rate depends on the slow step, not on the fast step. That any reactant that's involved in the slow step has order 1. Any reactant in fast step has order 0. So that means the rate depends on the halogenoalkane concentration. It's going to have order 1. And अच्छा अभी मैं सेंड कर दूंगा, ठीक है? अच्छा, this one. अच्छा अभी let me explain this very quickly. I'm going to explain the slow step part. I'm going to do another example probably. Achha, is this point clear that if a reaction involves two reactants, right? The rate obviously depends on the reactant one concentration and reactant number two concentration, right? We just don't know how does it depend. Anything that's got power zero, if anything has power zero, that basically gets eliminated from the rate equation automatically. That means the rate has no dependence on that. Anything to the power zero is one. And anything that's got power one, that means it's directly proportional to it. So that's order one. So how did I figure out order one and order zero? I figured out that I told you that if this takes 100 seconds and this takes 1 second, this is the overall mechanism of this reaction. Most reactions, they're multi-step reactions. They happen in many steps. So, I mean, this is a multi-step reaction. So Cl breaks off first, but that's a slow step. That takes 100 seconds, hypothetically speaking. Once the Cl breaks off, next step is OH minus 1 comes in and joins, and that's a fast step. What I was explaining was that no matter what you do to this fast step, the speed of the reaction does not depend on the fast step. But overall speed, that's 100 seconds and 1 second for this one. So the overall speed is 101 seconds, right? You continue to speed up the fast step. 1 second, you continue to make it faster. You make it 0.1 second, you make it 0.01 second, you make it 1 microsecond, 1 nanosecond. No matter how fast you make the fast step, the overall speed will still be close to 101. It's going to drop to 100 something, but it's just a negligible change in the overall time taken for the reaction. Is this clear that the fast step is kind of irrelevant to the speed of the reaction? Is that clear? So the first point is that the fast step does not affect how fast the reaction is. The speed of the reaction depends on the slow step. 100-second wala part, if you try to increase the speed of this step, if it grows from 100 seconds to, let's say, 10 seconds or 50 seconds, then all of a sudden, your speed drops to 51 seconds because it took 50 seconds for this, 1 second for this, and now it's 51. So all of a sudden, there's a massive increase in the speed of the reaction, right? So everything depends. I say everything depends on the slow step. So I'm just going to do another example similar to this. And remember, last time we did discuss that we had to talk about order two as well. So let me just do some simple examples first, and we'll discuss. I'll just make up some. I'll just make up some random. Some random examples. I would have to write it over here as a 1 second. My boards are not working, so I might have to change this. Anyway, so let's do another example. I've got a reaction, and the reaction is it's NO reacting with Br2. This is just another example. And NO reacts with Br2, and they end up producing two NOBr molecules. And it's 2NO. Now, remember, this is not the mechanism of the reaction, but the reaction involves two steps. The first step is, what's the first step? So I've got two things. I've got this thing, and I've got this thing. And let's focus on the rate equation. The rate equation will be that the rate is going to be dependent on NO's concentration and power X. I don't know how it's dependent on NO's concentration, and it depends on Br2 concentration. And that's going to be Y, right? So that's my rate equation. I have to figure out what X and Y are. So I'm going to make the reaction mechanism. So let's say this is the reaction mechanism. Somebody has figured this out. So let's say the mechanism is that you got, what happens is NO first comes in, reacts with one of the Br2 molecules, and when that happens, So when this happens, NOBr is formed. And one of the bromine atoms, it breaks off. Then the second step is another NO comes in, which then reacts with the bromine atom that's present, and they're going to react together, and they would form another NOBr molecule. So you got two NOBr molecules. Here, that's the overall mechanism of the reaction. You got two steps. So the total part is that two NO molecules, they react and they form two NOBRs. That's what's happening. Step one and step two. Now I'm going to write down that the first step, step number one, this one is our slow step. And this one over here, the next one, that's my fast step. So rate of reaction, on what step will it depend on? The first one or the second one? क्या होगा उसका क्या आंसर होगा? Which step is it dependent on? Okay, so rate is going to depend on the first step, right? It's the slow step. So remember this, rate depends on everything that's happening in the slow step. So that's known as the rate dependent. And that's my rate dependent step. So that means rate depends on NO's concentration and it depends on Br2's concentration, because if I change the concentration of NO and Br2, my slow step will speed up, which will speed up my overall reaction. Okay? Speeding up the fast step will have no impact on the overall speed of the reaction. So my rate equation will be that rate depends on NO. So rate depends on NO's concentration, and that's power 1. And it depends on Br2's concentration, and that's power 1 as well. So this is just one hypothetical example that I did. Maybe, so that's what I get from this. This is the rate equation that I get. These are the orders that I'm going to get. So maybe the mechanism is different. I mean, this same reaction can have a different mechanism. So let's say there's another different mechanism that has been proposed. And that mechanism is, it's this one. So I'm just making up another mechanism on my own. You can randomly just making it up. So I've got a Br2 molecule. What happens in this mechanism is that, initially the Br, it breaks homolytically into two Br atoms. And then in the next step, the NO molecules, they come in and they react with both Br atoms. And when they react, they produce two NOBr molecules. So they react and they produce two NOBr molecules. So that could be another mechanism where NO and Br2 react and they produce two NOBr, right? So let's say that's another, somebody suggested another mechanism. Now, in this case, let's assume that the first step is the slow step. And the second one is my fast step. So my rate will be dependent on the first step only, right? Rate depends on this one. Anyone who speeds up this one, that the rate will speed up. So this is my rate dependent. And that's my rate dependent step. I say in this case, now what will happen, that rate will depend on the concentration of Br2, because only Br2 can speed up the slow step. So that means rate depends on Br2's concentration, the other reactant, which is NO. it's not going to be dependent on that. So that means it's order 0. Anything that has power 0, it basically gets eliminated from the equation. So is this clear? This one, the second example for the same. Is this clear? So I got so based on mechanism, whatever mechanism is proposed, you're going to get the order accordingly, right? Bakyo clear? Anna, is this clear? Alicia, is this clear? I mean, you can write NO, but the point is it's going to get cancelled out anyways. Okay. Hold on 1 second. Let me reload the board. So I think none. I mean, the board hung up and nothing got saved. Just 1 second. So you would have to watch the video because everything got deleted for some odd reason. As anyway, so I'll move to order 2. How do we figure out order 2? As I'm going to use the same example that we were doing because I was just randomly making up the mechanism myself. So I'll just make up another mechanism. As I, so this part is, how do we know something is order 2? From the mechanism of the reaction. So, but remember the rule is anything in the slow step. Okay, anything in the slow step, the coefficient becomes the power. So any reactant in slow step. So coefficient becomes the power or the order. Achha, let's take the same example. Yeah, the reaction 2NO plus Br2, and together they were reacting to form 2NOBr. As remember, our focus is on trying to figure out how do we get order 2. So the mechanism is NO reacts with Br2. I'm going to use the first mechanism. Okay, let's assume that the mechanism is already given. They react together and they form NOBr. A bromine atom is produced. This NO goes and reacts with another NO goes and reacts with the bromine atom, and together they're going to form another NOBr molecule. And this time I'm saying that the second step is the slow step. I just made it up, right? So let's assume that the second step is the slow step. The first one is actually the fast step. So just as assumption, let's just assume that the second step is my slow step. If the second step is my slow step, the rate of the reaction will depend on NO's concentration, and it's going to depend on bromine's concentration. Okay, so rate would be dependent on NO's concentration. The power is going to be 1. And it would be dependent on the bromine atom concentration, and its power will also be 1. Actually, Yathak, is this clear up to this point that this is the rate dependent step and the rate depends on these two reactant concentrations? Is this part clear? Omar, Shian, Anna, is this clear? Jana, is this clear? So, but now notice one thing. These are not your reactants. Okay? Notice this thing that what you have over here is your reactants are NO and Br2. Now listen very carefully. This is where order 2 is going to come in. Look at bromine atom. When I say that the rate depends on bromine's concentration, this bromine's concentration, right? Where was this bromine formed? This bromine was formed in the first step, right? It was formed over here. It wasn't one of your reactants. It was an intermediate, right? So this bromine was formed over here. And the concentration of this bromine over here, the one that I'm underlying, this bromine concentration was actually dependent on Br2 and NO. So when I say that the rate depends on bromine atom's concentration, that bromine atom itself is dependent on Br2 and NO. That means if NO and Br2 concentrations are high, the bromine atom concentrations are also going to be high. So in a way, the previous step is kind of affecting this second step, which is the slow step. So what is bromine dependent on? Bromine is dependent on NO and Br2. So what I'm going to do is I'm going to leave bromine out. When I say that rate depends on bromine's concentration, bromine itself is dependent on Br2 and NO. So I'm going to replace that with, so I'm going to replace this one with NO and Br2. Right? So is this point clear that, that we stated that rate depends on the slow step? That means rate depends on NO and Br's concentration, right? So it depends on these two things. But Br atom concentration itself depends on Br2 and NO. Their concentrations are going to be high, then Br's concentration are going to be high. So we can say that if I say that rate depends on this one, rate indirectly actually depends on NO and Br2 because they actually make Br. Okay, is this clear? This working over here. You clear? Did you get this? So now what has happened is that your rate equation, so now what has happened is that your rate equation has changed. So remember this, that the rate equation is never going to include intermediates. You would have to get rid of the intermediates. Okay, intermediates are things that are going to be formed somewhere in the middle. Those intermediates themselves are mostly dependent on other things, other stuff, because other things, they make that intermediate. So now if I look at the rate equation, so how many times is NO appearing? Like if I bring the terms together, it's going to be NO squared. And Br2 would only appear once in the rate equation. So that's how I'm getting order 2. Okay, that's where I get order 2. So that means rate is dependent on, with respect to NO, it's a squared or quadratic relationship. You double NO, the rate becomes 4 times. Why does it become 4 times? Because if you double NO's concentration in the slow step will increase, right? But not only will NO's concentration increase, not only will this increase if you double NO's concentration. If you double NO's concentration, the Br atom concentration will also double. So the rate will increase again. So that means if you double NO's concentration, the rate will quadruple because the slow step will increase twice. First, because you're doubling NO's concentration, and because of NO's concentration, you're also doubling Br's concentration. So, which is why uh, it's going to be twice as fast. I mean, it's going to be 4 times. It's going to be a squared relationship. Uh, so the rate increases a lot more if you just change the concentration of NO. Is that clear? Because two of the reactants in the slow step, their concentration will increase. Just similarly, what happens is, why is Br order 1, Br2 order 1? Because if you increase Br2's concentration, this one, so what will happen? Br's concentration will increase. So that means only one of the reactants, its concentration increases. So if you increase Br2's concentration, the Br atom concentration will increase, and so that's only one of the reactant concentration increasing. So the rate increases proportionally, not exponentially. If you double NO's concentration, so NO is directly involved, so its concentration doubles. But because of NO, the Br atom concentration will also increase, and that will speed up the reaction even further. Hence, an exponential increase in the rate of the reaction. So what you're going to do is you would have to trace the reactants all the way back. So we'll do another question. Here, let me open a question. One second, let me find the question first. It's a reaction kinetics. It's 2020. Power 1 means it's proportional, right? The other one is it's exponential. You double NO's concentration, rate doubles, right? Because of NO. But rate doubles again because of Br as well, because Br concentration will also double. So the rate doubles because of this, and then rate doubles again. So that means it's increasing 4 times. That's exponential. So anyways, coming back to the, let me just find mechanism wale questions. Just 1 second. So I've, 1 second, is this, so let me, there's a way, so let's try this one. I'm gonna do the working over here. So let's try this one. I've got, so let's assume that, so he's saying it's C-step, use the mechanism to reduce the overall reaction. I mean, the overall is you add all the steps. Like if I add up all the steps, what will it be? Things that appear on both sides, they're going to get cancelled out. HClO gets cancelled out. OH ions and OH ions, they get cancelled out. What else getting cancelled out? I guess that's HIO and HIO as well, right? So the overall reaction is ClO -1 plus, I guess, I -1, and the product is Cl -1 and IO -1, right? So that's the reaction. I said let's focus on the. I said now let's focus on the mechanism. So the mechanism that we have over here is, I said, is this equation balanced? It looks balanced. I say anyways, now the mechanism is, I don't know if this question is exactly about that, but I said, let's say this over here, the last one, that is my slow step. So that means rate depends on these two things, right? So that means rate depends on, I said, that means rate depends on, hold on a second. I said, depends on HIO concentration, and it depends on okay, not this one. Just one second. Let me correct this. Let's say this is the slow step. So that means rate depends on I minus one concentration, and it depends on HClO concentration, right? But if you look at the equation, I minus one is the reactant, right? But HClO over here is actually an intermediate that was formed in the previous step. So when I say that rate depends on HClO concentration, it depends on these two things. HClO itself depends on water and ClO minus one. So I'm going to replace that by ClO minus one concentration and H2O concentration. And that's going to be my rate equation. That rate, in fact, actually depends on I minus one, ClO minus one, and H2O. Is that clear? You have a clearer example? Okay, so you got to remove the intermediates. I'm assuming I just assumed it. It's the slow step. Okay, right now, I'm assuming the mechanism is given, and I'm assuming that the slow step is already written over here. Okay, so that means rate depends on this and this. And HClO is the intermediate. So HClO itself depends on these two things. So I'm going to cut out HClO. I'm going to replace it with ClO minus one and H2O. So rate, in fact, actually depends on these two things. Let me just find. Just hold on 1 second. What is random maximum? Acha. Leave this just 1 second. Let me just find one question that's specifically on this. Just 1 second, Yapipita. I think it's this one. So this was specifically, let's just wait for this. This was the overall reaction, and they had specifically given you these steps, and they had asked you to figure out the orders. This was specifically on this. And they said that what will be the order, numerical value of the order, which is A, B, and C. That's the power over here. If step C is the slowest. So let's say this one is the slowest of all the steps. That means the rate depends on I minus one, H plus one, and HY, right? So my rate equation will be that rate depends on HY concentration, and it depends on H plus concentration, and it depends on I minus one concentration. All of them power one, right? But if you look at this carefully, you would notice that HOI is an intermediate. HOI itself was formed in the previous step. So when I say that rate depends on HOI, it's in fact actually dependent on IO minus one and H plus one. So that means HOI, I'm going to remove the intermediate. I'm going to replace it with IO minus one and H plus one. So rate actually depends on their concentration, not really on HOI concentration, because HOI was formed because of these two things. I said, then if I look at the rate equations, I'll notice that IO minus one is an intermediate. So when I say that rate depends on IO minus one was actually formed over here in the first step. And IO minus 1 itself is dependent on I minus 1 in H2O2. So I'm going to replace that with H2O2 and I minus 1. So that's my overall. I mean, I'm going to combine all the terms, and that's going to give me the overall order. What I did over here was the rate of the reaction depends on the slow step, and let's assume this is the slow step. The rate depends on this, this, and this. It depends on these three things. You increase the concentration, the slow step will speed up, and the reaction will become faster, right? But HY was an intermediate, and HY itself depended on H plus 1 and IO minus 1 concentration. So I replaced HY with IO minus 1 and H plus 1. And after that, I figured out that IO minus 1 is an intermediate as well. So when I say that rate depends on IO minus 1, it actually depends on the first step because of IO minus 1, rate indirectly depends on these two things. So I replaced IO minus 1 with H2O2 and IO minus 1 because these two things actually make IO minus 1. So when I collect all the terms, what do I get? H2O2 comes once. So H2O2 has a power or order of 1. I minus 1 is appearing twice. If I sum them up, it's going to be squared. And H plus 1 is coming twice as well. So that's going to be squared as well. So it's going to be order 2 with respect to H plus 1, order 2 with respect to I minus 1, and order 1 with respect to H2O2. TK, you clear? Is this clear? Yes or no? Is this clear? This example. And Shian. But there's no reason why you call it. I mean, I don't know why they call it order. It's just power. You've got 0, 1, and 2, right? Just remember 0 means doesn't really affect, it is not affected by it does not affect the rate. 1 means directly proportional, 2 means exponential, that means quadratic, that means you double H plus 1, the rate will not just double, it's going to quadruple. If you triple H plus 1, the rate will become 9 times. If you increase the concentration 4 times, the rate will increase 16 times. So it's a quadratic relationship. Okay. But is this clear, the first part, that if the mechanism is given to you and if you know the slow step, then you can figure out the order of the reaction. Is this clear? Okay, this is method number 1 of figuring out the rate of the order of the reaction. So okay, let's continue tomorrow then. Okay, everyone. Take care, Allah Hafiz.